Hey friends, welcome back to Make Anything. It's Devin here, as always. And lately I've been trying to focus on some larger and therefore more time-consuming projects. But I also miss putting out videos for y'all. So today I thought I'd walk you through a smaller holiday project that you can all customize and expand upon in the form of these fun little snowflake ornaments. I've been working on expanding my skill set beyond just 3D printing lately. And in the past year, I've acquired some pretty awesome machines, like the Make Block Laser Box, this 40-watt CO2 laser, and the Snapmaker 2.0, which includes a 1600 milliwatt laser engraver. Laser cutters and 3D printers are both super powerful tools for rapid prototyping and small-scale manufacture, with some pretty clear trade-offs. 3D printers can produce these super complex forms with ease, but they're limited in materials, with hobby FDM printers mostly just printing plastic filaments. Whereas laser cutters can cut and engrave a much wider range of materials, but they're generally limited to cutting flat sheets of that material. The great news is we don't need to use these tools in isolation. So for today's designs, we'll be combining laser cut and 3D printed parts to make our creations a bit more interesting. In fact, that's exactly what I did for my first special limited series of Astrolabicon puzzles. So here it is, the Series 1 Astrolabicon Atom Edition. This limited run of only 10 puzzles has been printed using some of my favorite top-tier filaments. And it includes this awesome stand with the edition number engraved onto a mirror. As I said, the combination of laser cutting and 3D printing can produce some extra special pieces. And that's exactly what my aim was with this limited series. I'm hoping that the extra finesse I put into these 10 puzzles makes them a collectible item that can be cherished. So if you're interested, they'll be available now through a link in the video description. So with that out of the way, let's look at how I made these fun snowflake ornaments so that you can create your very own invaluable collectibles. Cool. So the reason I started this project is that my sister is making a baby. I wanted to make some gifts for the baby shower, but all I really had was a sonogram. I decided to make a snowflake ornament that could maybe double as a coaster, since this is a winter baby, and I like multi-purpose things. I figured this grayscale sonogram is the perfect subject for a lithophane. Lithophanes are artworks that cast a detailed image when lit from behind, and it turns out 3D printing is a really effective way to produce them. Something as simple as varying material thickness can generate these incredibly detailed images. It's a really impressive effect, so let's go ahead and prepare our baby photo. So here's the snowflake I designed in Adobe Illustrator with an opening in the center for that lithophane. I'll bring that into Photoshop to make sure our baby is framed nicely. And while we're at it, I want to desaturate this photo so it's purely grayscale, and I'll adjust the levels so it ranges all the way from true black to true white for the best lithophane. I also had to add some details around the photo since it didn't fit perfectly inside this hexagon. Once it looks good, I'll save it as a JPEG. As I mentioned, 3D printing lithophanes is fairly popular by now, so there are several web-based generators to help simplify the process. Here's the one I like to use, so let's import that grayscale photo we just made. We'll go to the image settings and set the image to positive. And if we check out the model settings, well, they're already tuned for a good 3D printed lithophane, so we won't touch those. We can preview the file here, and we see that the black areas of the photo are the thickest in the model, so they'll block the most light. That's what we want, so let's download the generated model as an STL file and bring it into Microsoft 3D Builder, which is another free program as long as you have access to a Windows PC. Immediately, 3D Builder recognizes some issues with the model, so we'll click this box to automatically repair it for 3D printing. That's a really powerful tool, and while it's churning away, here's a look at the frame I designed for the lithophane in Fusion 360. This is just a 5mm thick frame with the edges tapering in, and we're going to combine this with the lithophane we just made so that it can nestle nicely into our snowflake. I'll save this as an STL so I can bring it into 3D Builder with our lithophane, and I'll align it lying flat on our ground plane. I've already modeled the frame to be the correct scale, so we just need to scale our lithophane to fit inside. We do want to maintain the Z thickness of 3 millimeters here, but for now we'll scale this uniformly to position it inside of the hexagon. Then we can click this little lock to turn off the uniform scaling and just stretch the Z height back to 3 millimeters so the lithophane prints properly. Next, we can use the settle tool on each part individually to ensure that they're laying completely flat on our ground plane, and then we'll select the lithophane and raise it 1 millimeter along the Z axis to center it inside of our frame. Now that everything is lined up correctly, we want to join the parts. So we'll start by selecting the frame and using the cut command to save it to our clipboard. Paste it back in place and then use the subtract command to trim the lithophane. We'll use the paste command again to bring back our frame, and then we can delete those trimmed edges. Before joining the two remaining parts, we want to ensure that their boundaries are slightly overlapping. So we'll select the lithophane once more, scale it up just a tiny bit, and then do a non-uniform scale to bring the Z axis back to 3 millimeters. Finally, we can select both parts and then run the merge command. That leaves us with a single solid mesh, so let's just orient this standing up again to prepare it for printing, and then we can save it as an STL. Now it's time to slice, and I'll be using Cura Slicer for this print since it has some useful settings that make for better lithophanes. For one thing, we can turn on user-specified Z-seam alignment and make sure that the seam is not running through the image. Here you can see some of those seam gaps visualized on the lithophane, so we'll want to tweak those settings. I'm going to turn the model slightly so one edge is clearly facing the back left corner of the build plate, and I'll set the seam position to that back corner. Let's also make sure to set the infill to 100%, and I'll use a 2-wall line count. Let's slice and preview that again, and this time we have that perfect seam running along this edge, and the infill is solid throughout, which should make for a good lithophane. Always inspect your slicer previews, that can prevent a lot of unnecessary failed prints. So I printed these up on my Ender 7 3D printer. It's a super rigid machine using a Core XY setup on linear rails, so I figured it's appropriate for these lithophanes. Surely enough, they printed out really well. I used a few different filaments, and the more opaque white definitely casts a stronger image, while the milkier white has this soft glow, so it could be a matter of preference. With that half of the equation done, let's move on to the laser cutting. I found these sheets of milky white acrylic at a second-hand store, and at 5 millimeters thick, I think they're just at the limit of what my laser box can cut through. I laid out several pieces in the LaserBox software and ran it with my previous settings for thick acrylic, which is basically a very slow cut at 90% power. The laser was just barely making it through, and oftentimes the smaller details got so hot that they melted back together. I was having my fair share of failed cuts, so I ended up cutting small squares of acrylic to cut each snowflake individually. After a while, I realized that I could get more consistent results by doing several faster passes with the laser. That way the acrylic doesn't get so hot while cutting. That strategy gave me some fairly clean cuts, and our lithophanes popped perfectly into place with a friction fit. We can already see the lithophane effect here, and when we hang this in front of a window, we get a really clear image, and the snowflake itself seems to glow. Awesome, so here's our first snowflake ornament, and by combining technologies, we were able to make it extra unique, with that 3D printed lithophane in the center, and the very clean, classy snowflake frame. Now, that's not all we can do here, since these frames and centerpieces can be easily swapped out, and since I already designed the snowflake, it was really easy to turn that into a model for 3D printing. I was even able to add a few extra 3D details with these chamfers, and then I figured why not pair that with some laser engraved wooden pieces to go in the center. It was back to the MakeBlock laser box for our wooden parts. I'm using the 3mm basswood sheets that MakeBlock themselves provide, so unsurprisingly, it cut super well. I also used the default settings to engrave this image, and it came out very crisp, but I was hoping for darker darks, and a lot of the subtle shading was lost. My second image really failed, and by tweaking the settings I was able to improve the results a bit, but to get a real dark image, I thought I might have better luck using my Snapmaker 2.0 and its laser module. I printed these rubber clips for holding things in place on my Snapmaker laser bed. I prefer them a lot over the included pins, and they made it really easy to set up my wooden hexagons. The Snapmaker 2.0 stitches together photos to help with alignment in the software, and when calibrated correctly, it's quite accurate and very handy. Once again, I'll just be using the default settings for engraving here, and the preview image already looks really great, so let's see how this works out. The Snapmaker approaches engraving somewhat differently than the laser box. This 1600 milliwatt UV laser has a fraction of the power of my CO2 laser, so it works more slowly. Rather than engraving in sweeping passes, this laser pecks at the wood, creating an image out of thousands of little burnt dots. It did take 10 times longer to complete, but the resulting images also came out much darker. Here are my different attempts side by side. The Snapmaker engravings are on the top, and the laser box ones are on the bottom. Let me know in the comments which method you prefer. Next up was printing the snowflakes. I'm using this beautiful Filamentum Extra Fill Gold Happens PLA, and, well, 3D printing is awesome sometimes, so everything just worked out, no problem. We'll pop in our center image, tie on a loop of golden string, and we've got more ornaments.
So, how cool is that? We were able to take one general design, this simple snowflake ornament, and by swapping out materials and techniques, we made several different, totally unique pieces. There's definitely a lot more that can be done with this idea, so I'll have all these files up for you to download and play around with at myminifactory.com. And if you do end up coming up with a fun variation, just tag Make Anything on social media, because I'd love to see what you come up with. Anyways, that's gonna be it for today's video. Thanks so much for joining. Happy holidays, tippy tipmas, and as always, stay inspired.